I haven't recorded on this particular app, so hopefully it works out okay. Hey, if you're behind on any sections, you've got to get caught up, all right? Don't forget the weekly agendas. You got to be turning those in each week as well. Okay, if you do turn them in a week late or whatever it is, you lose half a point. They're only 3 points, but you're getting points for just doing a checklist. Basically, the things that you're missing or anything you did late. Okay, if you don't do those checklists, you put the things like something you did late, or you don't send me a message on Remind, or come and see me in person to update your grade, I don't know to go in and update your score for you. Okay, and I would rather your grade be as high as it should be. So if you do anything late, you need to come in and let me know. Okay? Alright, so let's get back to this problem. Oops. Alright, and then I would do the one on top in orange. Okay? Where's my splitting point though? Does anybody know how to tell on a piecewise function? We only have one point where it's going to split or like do something different. Can you guys tell by looking at this piecewise function? Okay.
-2.
Yeah, it's -2. So not that we need to like make an imaginary line, but just so it's easy to think about, I'm gonna put like a little line there. You may want to do like a dashed line, that's fine too. Okay, so -2, things are going to switch up. Okay, normally the higher up the equation, that's going to be the more to the left type of thing, but you can always look at the inequality signs. X less than -2, does that mean you're going to be to the left or to the right of -2? If it's less. To the left, right? So if I just like made a quick number line, really sloppily, and I wanted to shade this in, this would be first of all an open circle, and then I would shade to the left. And then remember we like to use, if the variable is on the left, then the inequality sign points the way that we need to shade. Okay, since this inequality, well, first of all, since the x is on the left and the inequality sign is pointing to the left, then we're going to shade to the left. Okay, so that tells me whatever this equation is going to do, when I graph it, it will only show up on this side of -2. Okay? Does whatever my graph does it actually cross or actually touch this -2? Do you guys know? No, it doesn't. Okay? Or I don't know if you're saying no, you don't know, but no, it doesn't. Okay? Because it's a strictly less than. The one that actually hits through -2 is this one, and I can tell because it has the greater than for equal to. Okay? What color should we do the second equation in? I guess that'd be preference.
Green.
Green? This green? Fine. Not the other one. Okay? When I'm doing this one, it will actually, anything on this line that would show up, I will graph it. So it would be like a closed circle if I need to put that. And then this line is going to be the stuff on the right. Okay, now I'm not literally going to, I don't actually want to shade it that way. I'm just saying that when I graph the function, it's going to be on that side of the function, of the -2. Let's graph this first one. If you had this line, and let me change it into a slope intercept form, mx plus b. This would be like y is equal to -1/2 x plus 2. Alright? To ignore, let's ignore the little -2 as our splitting point. How would you graph this if we had a normal function to graph? What would you start with? The +2, yes? That would be your y-intercept. I would plot it right there. And then -1/2 tells me my slope is going to do what for my line? Down 1 to the right 2. Okay? So down 1 to the right 2, down 1 to the right 2, and then so forth. Okay? But remember, I don't really you might want to make this kind of line to help you visualize it, but I don't really want to lock it in. So if anything, I might draw it in very, very lightly because then I'm going to erase it afterwards. Okay? Now it's kind of like I don't know, some of you draw, or if you guys gone to like Disneyland where they do the animation thing where they teach you how to draw a character, and they tell you like draw very lightly until you know you want to like lock it in, then you go really dark. But I really want to be on the left side, so I'm going to have to go backwards. So to the right, up from my intercepts, to the right, up, to the left, and then up again. Okay. Now remember, I want the points on the left. The questionable point, so I don't really want these points right here. Okay? What about on the one that kind of goes down -2? And then I don't normally have that like that line highlighted or shaded. You can if it helps you. Eventually we're going to get into asymptotes, and that's going to be something a little bit different, so we probably won't end up doing this anymore. But on -2, how do I differentiate since it cannot be on -2? What would I do on the number line? If it's strictly less than, what would I do on the number line? Well, as far as right here, I did put it on -2, but how did I like signify that it goes all the way up to -2, but it doesn't actually hit into it? It's going to be an open circle. So this line this particular dot right here, if anything, I might just put like an open circle there, because it's going to go all the way up to that point. Now, I'm going to get rid of some of the shading here, and I can draw in this line right here. Okay. That particular function, that particular line, is only going to look like this until it gets to -2. And actually, it like doesn't actually get to -2. It's like as close to it as possible. Okay. Now I'm going to put that little line down -2 again, just to think about how we're breaking it up. Now, the one that actually crosses the y-axis is usually the easiest because we get to use the y-intercept and we can lock in the line. But let's see, let's do that one green. How would you start graphing 1/2 x minus 3? Yeah, your y-intercept is at -3. Remember, y is going to be up and down. So I would put a point right there. 1/2 tells me I go up 1 and to the right 2. Okay, and then I'll just continue that. Up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Now I need to kind of go backwards to fill out my line. So I will go down 1 to the left 2. And then is this an open circle or a closed circle? Closed. This one's closed. Now I can lock in that line to the right. If it was really helpful, we could make the dashed line of what would have been for green, and we could have done the same thing for the one in orange. If that's helpful, you could do it of what would have been, except I'll just maybe leave it dashed because that's not what I really want. But you can do that if it's helpful. All right. Now, this is this little highlighted line that we use just to kind of help us keep in mind of where we're breaking up the graph. It's also convenient because I can tell how does this prove I passed my vertical line test? Even though I kind of have things that overlap each other almost.
Oh, because the orange line isn't onto.
Yeah, because the orange line is open circle. And so even though it looks like I could have a million open circles right here, but as long as there's only one closed one, it's going to be a vertical. It would pass the vertical line test. Okay. All right. So that's the graph. We need to consider domain and range. What does the domain tell you? Does anybody remember?
And down.
It tells you close, left and right. If the domain tells you left and right, what does your range tell you? Up and down. Okay, so I don't know, I feel like range would be a little more convenient if it was left and right. And then like, I don't know if you guys heard the song, the really old song, Home on the Range. You know what I'm talking about? It's a really old song. I learned it in elementary school. Okay. But I feel like range, like, or if you think of like a ranch or like a range, I would think about something that goes sideways, but I don't know, I would have to think about that one. But your domain, I like to think about, that's going to be how far, this is going to be your left/right, okay, your possible x values, okay. Sometimes I also will describe it as like, if you're thinking of a room or a house, it's your walls. Okay, so like when I think of walls, I don't like think up and down. I think of like walls going to the one side of me and then to the other side of me. Okay, so maybe your walls. And I always want to talk about my smaller one to my right, my left one, okay? As far as this graph, how far to the left could I go? Like, as far as like, okay, I'm going to have to go point this way actually. As far left as possible. So there's a few different ways to write. Johnny said all real numbers, and that's a short one thing that we can say. But if it goes this way forever, a lot of times we think of like to infinity and beyond. In this case, it would be negative infinity and beyond, if you want. Okay, so it would be like negative infinity. How far to the right? And then this is my x values. How far to the right would it go? Is there any particular part where it stops? No, it doesn't. It would go as far as possible. Okay, so one thing we could say is all real numbers, because x could literally be any number. Okay, but writing it in this inequality format is helpful to think about as far as like left to right. And it's even easier to think about it for x's because we can think of like the number line. Okay? X can be bigger than negative infinity and it's smaller than positive infinity. It can't actually be infinity because we can never actually reach it, so you can't say, oh, it is equal to infinity. What about range? A lot of times range is the tougher out of the two because we actually will run into something that's not all real numbers. Greater than or equal to. So when I'm thinking about range, not that you're wrong, but when I'm thinking about range, let's think about these little examples. Left or right, I'm thinking about, I think it's more natural to say up and down, but I want to think down and up, just so it matches, okay, because we always do the lower part first. What about for this part, what would I say? Possible y values. And of course, guys, like these little things that we're thinking about, these little memory things to think about, you don't have to write these down unless it's helpful for you. When you get to this problem, write it down. Okay, really what your answer would be either this or it would be this. Okay, for at least your domain. What about walls? What would you say instead of walls for a range? Ceiling. So I would be thinking of like either the grounds to the ceiling or the floor to the ceiling if you have any of those. Okay, so it would be like your, I guess you put floor and your ceiling. How low does your graph go? That would be your floor. How high does your graph go? That's your ceiling. That's like you cannot go past that if you have a ceiling. Sometimes you don't have a ceiling. Okay? Alright, maybe houses in progress being built, or maybe you didn't have enough money or something happened. Sometimes, usually you have a floor, okay, but maybe there was a sinkhole or something, and I don't know how deep down it goes, okay? Say it goes on forever. It doesn't know, but. Alright, So Johnny, you said for our range, before we even start talking this, you were saying greater than or equal to 4. So let's think about y, and then I'll use that inequality again. Is there a low point or a floor or a like minimum that we could actually get to? -4. So I want to put that. These are like this is my minimum right here. Now sometimes you don't really have a minimum. So like when we did the x's, we didn't really have a minimum. It would be -infinity, so we don't have to put inequality. Is there a maximum? No. So I don't really need this side here. Y is just going to be greater than or equal to -4. Okay, and if you want to switch it so the y is first, then you can do that too. If it did have a ceiling or like a high point, then you would include like 2 numbers on each side. 1 number on this side, 1 number on the other side. Okay? Pardon?
Isn't it greater than?
Yes, greater than or equal to. Thanks. Alright. This one I want to put greater than because for that y value, when it goes to -4, it is a closed circle. If it had been an open circle, then it would have to be strictly greater than. Okay? The difference for over here when we had strictly less than or strictly greater than, it's because we were going to infinity and we can't actually be equal to infinity. Or negative. You guys ready to move on to 2? Okay? Alright, so now we have kind of the flip. We have the graph and we need to write the piecewise function. Okay? Let's do at least A, and then if we need to do B, we'll do B. When I do a problem like this, I like to think about, kind of like when we were graphing, when we looked at this one here, and we kind of highlighted this line right here to help us think about where does it break off, or where does the graph change up. I would like to think about, well, from the graph, based on the graph, where does it look like it's like things change? Where maybe it's like doing this like zigzag thing and it stops and then just goes down. Okay? Where can you guys tell where that point would be?
2.
It would be at 2. How many different types of lines or graphs do I have on that one? 2. So then I want to have 2 equations, both of them involving 2. Okay? And then like we said, so I'm going to put this like kind of dashed line right here. X values and then X values, if they are 2 and 2, this one here would be less than, that would represent to the left of 2, and then the bottom one would be greater than 2, representing anything to the right of 2. Which one gets the or equal to? The less than, so the top one, right? And I know that because if I'm following this line, it goes all the way up to that like split in the graph, and it has a closed circle. Okay? Whereas this one here starts with an open circle, but then it goes on forever. Okay? You might have seen in some of the homework problems, you have like more than just 2, we have like 3 parts or more. It just means you have extra breaks in the graph where just something completely. Okay? Alright, so we've done problems like this where you look at the equation and then you try to figure out, you look at the graph and then you write the equation. Alright, which one would you guys like to do first? The top one then? That make logical sense. Okay, so let me say we're doing this one. I would like to know what my y-intercept is. Right? If I'm trying to get it into this mx plus b form, it is nice to know what my intercept is. What is my intercept in this case? -1, right? What about my slope? It looks like it's going up 2 over 1. So I could put 2 over 1, or I can just write the 2, and that would be 2x. And then maybe the one on the right's a little bit tougher because it's a slope, it's like a special case. Alright, but I can still think about it the same way. Where's that? Where would the y-intercept be? Like if this one, even though it doesn't go to the y-intercept, if I made like an imaginary line that went through, it would cross through 4. What kind of slope does this have? Does it go up? It goes up 0. How much to the right does it go? It does, I mean, I could pick because I could say it goes over 1 or I could say it goes over 2 every time. It says go up 0. Well, okay, so I don't go up at all. And then go to the right 50. And that would still like work out with my graph. Okay, but since whatever you choose, some of you guys said 1, what is 0 divided by 1? It is just 0. So if I were to put a 0 times x, that is just 0. That's why you normally never see 0x unless they're just kind of explaining it more in detail. So this is actually my equation for the second one. Okay? That's it for number 2a at least. Do you guys want to try, or do you guys want to go talk about 2b as well? Anybody? C? No? No? C? Are you going to move on to 3? Alright, I'll take that as a move on to 3. Okay, so for example, by the way, guys, like we did like we did the 1a example. Okay, you will only see like one problem like that on the test. You won't see a second one, but you get an extra example to practice. Okay? For when you get to number 2, there is an A and a B. Okay? But they're like similar concept. You're writing out the piecewise function. Skip over example 2b. Let's talk about example 3 or 3a. So on a trip, so these are like the closest to word problems we almost get. Alright. On a trip, the total distance you travel in x hours is represented by the piecewise function. Okay? Let's look at this piecewise function. How does anybody know how to read that off then if we're talking about miles or like what if I go 2 miles? Which one am I supposed to use? I have 3 equations, but I don't use the like all 3 equations. I only use a particular equation given the number that I start with. If I'm using 2, which one does 2 like fit? And I'm not looking at anything on the left. Alright, I'm looking at my conditions on the right. Because the conditions on the right tell me when do I use 55x, or when do I use 82.5, or 82.5 plus 320 times the quantity of x minus 4. Okay.
Second one.
The second one. How do we know the second one?
Well, because if it says that x is hours, you're saying like 2 hours, and you just put 2 where the x is.
Yeah, we said 2. We're thinking about, well, where would 2 fit? 2 does not fit between 0 and 1.5. Okay? 2 does fit. Like, I could put a 2 in there, and that would be a true statement. And then 2 is not greater than or equal to negative, or positive 4, I should say. Okay? Alright, let's check out A. What if, how far did you travel in 3 hours? Well, I want to think about which equation would I need to use for 3 hours? The second one, yeah. I know it's the second one because it falls in between 4 and the 1.5. Okay, so if I want to use the second one, then I plug that in, and I could write it in this function notation. D of 3 is equal to, and I'm using the second equation, 82.5. Do I need to plug the 3 in anywhere? No, because there's no x. So actually, that's my answer, 82.5. So that one's a little bit easier because there's no like variable to plug in. Probably if we're going to use A or even like, or not A, the first equation or even the third equation looks a little bit ugly. Okay? What if, and then what if I travel 4.5 hours?
Use the third.
You use the third one. The third one because it is greater than or equal to 4. Okay, so if I'm using the third one, d of 4.5 is equal to 82.5 plus, I'm running out of room, 320 times, you plug in the 4.5. If you want, you can put that in parentheses, minus 4. Alright, and then I solve. First thing I need to do is, what's the first thing in order of operations? I need to simplify before I like do anything. What's the first thing that follows or comes up in order of operations? Parentheses. Do I have anything parentheses-wise that I could do? Yeah, I have a 4.5 minus 4. So let me move this over here. 82.5 plus 320. 4.5 minus 4 is 0.5. Okay. Now maybe you're at this point you'd be reaching for your calculator, but what's the nice thing about multiplying something by 0.5? You just half the thing, right? So it's like thinking if there were 200 points and you got 50% or 0.5 of them right, and 200 points you only got half of it right, you'd have 100 questions right. Okay? Or 100. So I could just easily do 82.5 plus, can we do 320 in our head, divided by 2? Marty?
160.
160, okay. I thought you said 360. I was like, that's the wrong direction. Alright. Okay. 82.5 plus 160, what is that going to be? 242.5. And then if you want to, you could put MI, not from Michigan. Mile. On algebra? 2? That's up. Okay, that's your answer. And by the way, this would have been the first one. If you don't put miles, I'm not going to dock you unless it's specifically ever said. Make sure you write your units. Okay, I'm going to make a little bit of room here. All right, for C, which one would you use? Okay, this one's why is this one like? Why do you have to pause and like do a double take on this one? Yeah, it's exactly 1.5, and 1.5 shows up 2 times. So I like that you said the second one. Why did you pick the second one instead of the first one? You haven't even used the first one. Don't you want to use the first equation though?
It's because greater than or equal to 1.5.
Yes, greater than 8. This one could be 1.5. So then that's actually really nice because then I already know what the answer is going to be. It's going to be 82.5. D of 1.5 is just 82.5. Or D of 1.5 is 82.5 miles. Cool? Alright, so hopefully you feel good about that one. Maybe you see like, oh, I have to read something for A, B, and C and the instructions, but hopefully after going through this you feel pretty good about it, and after you do the extra example you'll feel good too. Okay. Unfortunately, we did the easier one. Looks like all of these ones here you have to do a little bit of math, no matter which one you pick. Okay. All right. Number 4. So I didn't actually give you an example like A and example B for this one, okay? Because on the test, it's going to ask you kind of questions about arithmetic sequences. Okay, so we may not hit everything right now while we talk about it, but what are some things that you would have to think, like what could Mr. Tate ask me about arithmetic sequences? Or what are some important things, or like what makes something an arithmetic sequence such? There's a common difference, okay? So there's a common difference. What is that? Then you want to elaborate too. But I don't know if everybody was here last week, but let's talk about arithmetic sequence a little bit more. So what is it? So if an arithmetic sequence has a common difference, what does that mean?
For these, you should just be writing the because you're gonna get like
Difference between each number.
Yeah. So and then I didn't hear the first part, but I heard pattern from Johnny. The pattern is, as Doug was saying, is it's a constant difference. So whether you are from one term to the next thing in your list, you are going either up a certain number every time, or you're going down a number every time. So you're either adding, like say you're adding 25, then you add 25, add 25, add 25. Or maybe you subtract 50, subtract 50, subtract 50 to get each number after that. Okay? So any number of those things, let's see, common difference, every, what's the other one, the other word we use instead of number for the list? Term. So every term goes up or down the same by the same number. Okay. What about formulas? What was we did talk about a formula last week. What was the formula that we had? And then just, this may or may not be asked, but other little things like you might want to say, or you might be thinking like, oh, okay, like the first number in, the first number or the first term in an arithmetic sequence, I can denote that also by saying like A sub 1 or subscript 1. That would be like the first. And then if I had A sub 100, that would be like the 100th. So maybe I won't ask you this specifically, but this is something that you should be able to understand. Okay. What about A sub n? What does that mean? We talked a little bit about that last week. What does A sub n? Where does that show up as far as the homework or anything we've done? Do you guys remember what n stood for?
Like any number.
Yeah, any number. Okay, so sometimes in like math, you get a random variable that stands for something and doesn't make sense. Like I don't know if we talked about it last week, but the set of integers, instead of using a big I for the symbol, they use a Z. Rational, they use a Q. Okay, you would think maybe an R, but yeah. Maybe that's not really what the n stands for, but I think any number means the same thing. Okay, what was the formula that we could use for this? And when we did the, like we had extra credit last week, right? Or the little, like, I think it was the quizzes that we did in this class. You had to use a particular formula every single time we did a problem with an arithmetic sequence. What was that formula? A sub n is equal to what? A sub n is equal to A sub 1, that's a start. Then what follows? Plus.
Parentheses n minus 1.
Good.
And
And it's going to be times to that d. Okay? If it's helpful, you can put like d times n minus 1, switch up the order if it's helpful. A sub n is like any number that we're looking for. Okay, that's the formula we use to find the nth term. A sub 1 we already talked about, that's like our first number. N would be the number we're looking for, so I'll just put a number symbol. And then what does D represent? Yeah, the common difference. So D represents, and I'm just going to be lazy and just circle that with a little ugly arrow. Okay? So you just want to review some of that. Okay, definitely you should review it because you'll notice the next few problems all deal with arithmetic sequences. So that would be a quick, helpful review before you try to do these problems, and then it will help you look back and forth. Okay. Let's look at number 5. Determine if a sequence is arithmetic. If so, find the common difference. So remember, if it is an arithmetic sequence, it does have the common difference. Like that was the very first thing that Douglas, I think it was Douglas that brought up, or maybe Johnny brought up. Okay, so if I'm looking for a common difference, I'm checking to see from the first number to the next number, how much do I add or subtract? And then, okay, say it's plus 99, the next one better be plus 99, and so forth. If it's not arithmetic. Okay? So from 12 to 17, how much do I add or subtract?
5, 4, and 5.
Plus 5, right? If this is an arithmetic sequence, the next thing better be plus 5. What is 17 plus 5?
22.
22. Okay, it looks like we're not there, right? This is actually a plus 4. And if I wanted to keep going, I could, but at this point, it's could not be an arithmetic sequence at this point. Okay? Yeah.
What goes like plus 5, plus 4, plus 3, plus 2, plus 1?
That would not be an arithmetic sequence. It could be a sequence with a pattern that maybe we could write a formula for, but you could not use this formula that we have up here. Okay? And it's not an arithmetic sequence. Okay? I think last week we talked about ones where you multiply by the same number every single time. Okay, that would be a geometric sequence. There's other like equations that kind of take like where you take the first number and the second number, you add them to get to the third number. Okay, then you take the third and the second number to get to the fourth, and then the third and so forth. I don't know, I'm losing track, but all right. So this one's not arithmetic. Not arithmetic, you might just want to say no common difference. Okay? If you don't write this on the test, I probably will still give you full credit. This probably be like 1 point. But as far as going back, just look at your own notes just to study this may be helpful to think, oh yeah, that's right. It didn't have a common difference, that's why it's not arithmetic. Alright, let's check out 5b. From -10 to -3, how much am I going up or down? We're going up 7, so that's a plus 7. Alright, in my head I'm thinking, well, I better get plus 7 to the next one. And I believe we do here, right? And then even one more time. Okay, so just check all of them. I don't think I tried to like trick you where like the first 50 are right and then the 51st one is like off. Okay, you don't have to get that many numbers, but just double check. It's like one extra calculation of adding 7 to make sure it's good. And then guys, I don't know if we mentioned it last time. What does this little ... imply?
That it continues.
It continues with the same pattern going on. Okay. Cool. Oh, okay. So this one is arithmetic. Is arithmetic, and then you can either say the common difference is, or we could use D is equal to positive 7. Cool.
Can't you just say so?
If you put 7, likely I would give it to you, but it's not harmful to think about it instead. And you're using a different type of formula if you want to put that in. Okay? Alright, so 6 and 7, and some of you guys stayed after and we talked about this problem, or I helped you in the middle of like the little quizzes. We didn't talk about this in class, so I think this was like one of the most missed problems from that quizzes we did. Okay, what do you do when they? Okay, never mind. 6, I'm jumping the gun. I was thinking about number 7. Okay, we'll go back to 6, but let's look at number 7 since I already started to do that like little intro. Okay, what do you do? Like, I know the formula, and the formula, I have to know the first term, and then the number I want to use and the difference. What do you do if you don't know the first term, and that's the one you're looking for? Because in 7a, they don't give you a1, or a sub 1. They give you a sub 27. How can I use that? What's the formula? Let's think about, like, because that could be helpful too for any of these arithmetic sequences. You might just want to write that formula down real quick in case you need it. What is the formula for the nth term? What is that formula? A sub n is equal to a sub 1 plus n minus 1. And sometimes you might see the d written first. Does that confuse you if I write it switch or swap? Okay. But, like, remember that n stands for any number. So could it stand for 27? Sure, why not? Okay, but let's apply that here. I know a 27, so instead of n, I want to write a sub 27. Alright? Is equal to, I don't know my first term, so I'll just leave it a sub 1. Okay? They do tell me my difference. Since it's positive, I'm going to put a positive, I'm going to put a plus 2. What do I write in the parentheses? 27 minus 1. Maybe some of you guys can do that in your head and you just write 26. Good for you if you can do that. Okay? Hopefully you can do that. Okay? So you guys might even skip that step and just go a sub 1 plus 2 times 26. Oh, and I actually know what a sub 27 is equal to, right? What is it equal to? 781. Okay. Alright, now don't let the fact that there's an a sub 1 that you're trying to solve for throw you off. If this was just an x, you guys would know what to do. You would say 2 times 26, and then I would have to subtract 52 from both sides to get the x all by itself. It's not an x, but it's still an unknown variable at this point, because I'm using a sub 1 to use it to represent an unknown. 2 times 26 is what, guys? You might have heard me say it already. 52. Then I need to subtract 52 from both sides. What is 781 minus 52? What did we say? Pardon? 729? 729. Okay, so that's my a sub 1. Alright, now that I know my a sub 1, I could apply that to my regular formula. So in case I wanted to know what a sub 500 was, now I can use a sub 1 since I know it. So I would go so remember a sub 1 plus d minus, or times n minus 1. Maybe you switch the d and the n minus 1 because that's normally how you see it in the book. I will put 729 plus 2 times n minus 1. Okay? I don't want you to stop there. I want you to keep going. Okay, because this can be simplified. 729 plus 2n minus 2. Everybody okay on the 2n minus 2? Okay? And then I can go a little bit further and say, I'm going to put the 2n first as well. Plus 727. I gotta go. Okay. You guys okay with that? So far, that's 7 problems out of 10. If each problem was literally worth 10% of the test, like, feel good, then maybe you're at a 70% on the test. We know the problems aren't always like exactly equal to each other. Oh, actually, we have to get to number 6. All right, and then who has? Does anybody have? Was English 10 today or 11? 10? You guys have English 10? Well, let's go through 6. If you have to leave, you can leave. If not, then you can stay through, and then hopefully it's still recording. If not, you can just put it after it. Okay. Number 6, write an equation for the nth term. Remember, when they say an equation for nth term, you're looking for a sub n. Okay? Which is this formula right here. Okay. Then find a sub 88. So there's a few things I do need to know for this formula. I need to know what my a sub 1 is. That should be the easiest part of this problem. What is my a sub 1? -3, yeah. Remember, a sub 1 means it's the very first number in the list. Okay, then the difference, the common difference, shouldn't be that hard either, but it does a little bit of work. And it's a plus 2, because every time I'm going up plus 2. So I can plug that into my formula now. A sub 1 was -3 plus 2 times n minus 1. I want to distribute the 2 to the n and the -1. I get a plus 2n and then a minus 2. And then I combine my like terms. What is -3 with -2? -3 with -2 is what? -3 with -2 is what? -3 with -2.
Oh, it's 2.
Not quite. -3 and -2.
Oh, it's.
Not quite.
I don't know what you're asking me. I'm doing something else.
-3 and -2
What do you mean?
combined. Adding.
Oh, it's 5.
Not quite.
Where is it on your paper? Oh, -5.
Negative. Okay, good.
I'm doing something else. I'm
I can
finishing
tell
the
that you,
problem.
I think you said like 74. And I'm like, there's no way you got 74 from -3 and -2. Unless you did like some weird repeated multiplication that added some numbers. Alright. You guys will notice too, normally I like to put the n term first. Okay, that kind of matches like standard form, and we'll get into that when we get to chapter 7 when we start dealing with polynomials. You always list it in a particular way. Okay. So that's my formula. I can use that formula to find a sub 88. I would just say 2 instead of the n, plug in 88, subtract 5. 2 times 88 is what? 176. And then when we subtract 5, we do get 171. Okay?
That's what I was trying to get.
I figured you were going straight to the final answer. I was like, Okay. So that's all the way up to 7. Oh, okay. I was like, 1 second. I thought I gave you the same project again. But okay. Let's talk about number 8. This should have said example 8b down there. Not that it's much one, but oh, did I copy the? Oh, I need to switch up your extra example. I'll copy that up later so you guys can practice it. Let's look at example A. Example 8AA. Okay. I just want to start out by plotting the points. Okay, so let's plot this in like this darker blue. -2, 5. Okay, we need some review on plotting ordered pairs. You guys need to come in and get that as soon as possible. Negative 1, 4, 0, comma 2, 0, comma 4, 1, comma 2, 2, comma 1, and then 3, comma 0. And then we'll talk about the correlation in a second, and we'll make a little line as well. Let's quickly graph the one for B. Okay? Negative 3, comma 4.5. Negative 2, comma 4. Negative 2, comma 3. Negative 1. Oh, did I, this was really hard.
We can't count exactly the ones. So that's where they use the distance.
Negative 1, comma 3. Negative 1, comma 2. 0, 0. 0, 1. 2.
But here, we can't exactly.
Negative 1.
Accurate. And it doesn't count perfectly. So that's what we use.
Okay, so these are, don't give you a lot of variety, so I'll try to give you a little variety for example 8B. Can we make, like, what would our line of best fit look like? It would look like it's going like a downward line, right? So like, let's make one here, and then there's not really, I mean, there's technically is an exact science to finding the perfect line of fit, but as far as us, like, I'm not too worried. Even though most of our points kind of go down like this, I do have a point that's really far away. Does anybody know what that's called? It's not something we've talked about yet, but it starts with an O. It's called an outlier. So it means like, oh, like, we use the example a lot too, like, oh, the time, the amount of time you spend studying and the time you get, the grade you get on the test. So like normally the more time you spend, the better you do, but then there's always maybe that one kid that didn't study at all and they still get 100%, or there's the kid that studied a ton, but then maybe did really bad stuff. Okay, those would be like outliers because it's not really what we expect. But I would make the line a little lower just because of that outlier is going to pull the line down. I think those points are, I think the, I accidentally copied the same thing. So. Or did I, yeah, I think so, your points should look almost exactly the same. Okay. Let's look at B. It would also be kind of like this negative line that's going down. Okay. What type of correlation is that? Does it have correlation? It does. Positive or negative? It's going to be negative. So if we can get a line that looks close enough to all the points, then it's got some correlation. If that line is ended up going down, it has a negative correlation. If it was going up, it would be positive. So these are actually both negative. Real quick, I want to show you, not that these, ignore these points for the moment, because I'm not going to use them to talk about when you would get positive or like no correlation.
It's not showing up on screen. Screen is closed.
Really close. That's like a Wi-Fi issue or just the actual app? Okay, so let's look at like, and I said, don't ignore those points because I just randomly plotted those points, so they shouldn't match up with the other pairs. If they did, that was just like weird coincidence. Okay. Of the two, and I want to talk about positive or negative, which one would have no correlation, or I should say positive and no correlation? Which one would looks like it has a positive correlation? Which one looks like it doesn't have correlation?
B.
B would be which one? B would be the positive. Okay, so it's not perfect. Let me make the line a little thinner. But it does look like they are all basically going up to the right. Okay, so it's a positive correlation. Now, the fact that they are a little bit further away from my like line of fit, it means the correlation is not as strong, but it does seem like there's a correlation nonetheless. Okay. What about this, for example? Like, where would I draw my line of fit? It kind of looks like my points are all over the place, and normally when it doesn't really look like there's a strong correlation at all, if any. So usually, if there is no correlation, you would normally try to draw a line down the middle, left to right as much as possible. Okay? Because I have so much going on up there, so much going on down there, and there's not really a pattern that like any type of trend, there's no correlation. This would be none, or no correlation. And this one would be positive correlation. You guys feel okay about those types? Sure. Okay. I'm not going to have you calculate like the residuals. I think that comes up in the very last section that we do. But drawing a rough line of fit shouldn't be too bad. Okay. We have two more to do. Let's check out number 9. Okay. Table shows the number of people, X, in a room and the temperature of the room in degrees Fahrenheit Y. Okay. So what we want to do to start is make a scatter plot using the data, then create a line of fit, or a best fit, identify the type of correlation, and then maybe a sentence of how do you know it's positive correlation or negative correlation or that there is no correlation. Okay? So the first thing we have to do is just start by plotting those points. Okay, so you guys can do that on your own. You don't have to look up and match mine. It'll probably be faster if you look at your paper. Alright, 0, 76, 176, 277, 377, 478, 579, 679, 780, and 82. Okay, that's part A. Hopefully not too unreasonable. Create a line of fit, or best fit, I should say. Just trying to get it down the middle as much as I can. That's B. What type of correlation do we have? Positive. And how do we know? Going upwards. It like has, for one, the points are close enough and it has a positive slope. So a couple things, and maybe not necessarily in this order. Positive slope, the points are, and we know that there is correlation because the points are relatively pretty close to each other. Okay, now you can word it slightly different however you like.
So, when you're saying what is a correlation, are you saying that there's a positive effect kind of thing?
Correlation does deal with like positive effects. You have to be careful because there could be a correlation, but not necessarily that they're related. So It could just be like maybe there's a third variable that we're not considering, and that actually has a bigger role, or it has like all of the role. So, like if you're thinking about, if you want to get really detailed, like the amount of time a student spends studying and the grade they get, well, it's not really just that simple. You would really like even want to break it down further. Like how much time do they go in to see the teacher? How much time do they do this? And there's all these different variables. So one might have a bigger cost than something else. Okay. And it could just be more of a coincidence. If it's a coincidence, it may be correlated, but it may not actually be what caused it. And I think they talk about causation in the very last section that you guys do, if you haven't gotten to it. Okay? All right, number 10. Tell whether a correlation is likely in the situation and then explain your reasoning. The height of an adult and the level of their intelligence. Do you think that's correlated? What if it was correlated, what would that mean? If there was like, oh, there is a correlation between how tall an adult is and how smart or not smart they are. Yeah, it's like, oh, if you're 6 feet tall, you're pretty smart, but if you're 7 feet tall, you're really smart. Or maybe vice versa. Like, the taller you are, the like less intelligent. There's not really. That doesn't seem like it is, right? So I would put. Let me get this in. No, and then you can just say like, intelligence is like does not rely on how tall or not tall you are. Okay. Now I specified as an adult because then if I didn't specify adult, then maybe you would think, oh, someone taller maybe is older, so they are a little bit smarter. If they were a kid and they were shorter, maybe they wouldn't be as smart as an adult, but specified for an adult specifically. No intelligence. I should put height doesn't impact your intelligence. Now we could do something though, like maybe there's like maybe the taller you are, maybe there is a trend that you are smarter because maybe you go to class and you can't see if you're shorter or something. Still not working out. Wait, I'm trying. All right, and then we've got one more. The time spent on your phone with the amount of battery charge left. Okay, and then I put like you're not walking around with like a portable charger or something, or you're not having your phone plugged in the whole time. Okay? Do you think that there will be a correlation that exists there? Yeah. Did you grab one? Mm-hmm. Yeah, okay, so I would say, I would reason yes, and there could be like, you could possibly reason like yes, and another person could possibly reason no, and if your justification is good enough, then you can still get the full points either way, okay? I would say yes. I would even put, so if I do think there's a correlation, I would say the more time spent on phone, what would you think that would impact your battery charge? Yeah, so then unless maybe your phone's a little old and then it seems like you do an update and then just But it just happens to die a lot faster for some reason. Okay? So we've done one of every type of problem. Okay? Finish out the rest. Okay, and then you guys will turn this into me when you turn in your chapel, I guess your unit 7 notes. Okay, so your unit 7, and we went out of order, but when you printed them out, they should have the number on the top right corners for you to staple them in order for me. Make sure your name's on it, because if you don't, that's like 20 to like 45 points sometimes, depending on how big the unit is. Okay, make sure you have your name on it. You'll turn your notes in, you turn this review in, and then you can take your test. Okay, you don't get to use your notes on the test, but you can use this as much as you need beforehand to help study, and you'll come in. If you need extra problems, you can come in and ask for those. Okay, you technically have until next Friday. I would not recommend that. I would recommend that you use the rest of the week, the weekend to study. Come in Monday, maybe ask some questions, and take it Monday while it's fresh, and then start the next chapter so we don't fall behind. Alright, guys, have a good day. If you need to use this as a work sample, you can make a copy and then just show me.